Thank you for joining us today. My name is Kurosh Lohorasbi and I'm a solutions architect based out of Sydney. In the next 30 minutes, I will be covering Amazon SageMaker and how to build, train, and deploy machine and deep learning models fast, cost-effective, scalable, and secure. This is an advanced level session and it is expected that you're familiar with the basic data science and machine learning concepts. However, if you're not a data scientist or a machine learning engineer, I would still encourage you to stick around, as I'm sure that this might be a good starting point. Okay, let's set the scene for SageMaker by quickly reviewing a typical machine learning pipeline from an idea to production. Like any other great project, a machine learning project starts with a business problem. The next step is for data analysts and data scientists to confirm if the solution can be implemented using machine, deep, or reinforcement learning. This stage requires vast amounts of domain knowledge to be captured by the data scientist and business analyst, and also decisions to be made on what datasets to use. Then to run this machine, we need fuel. I cannot overstate the importance of data, and specifically clean data, in a successful machine learning solution. At the end of the day, your models are only as good as the data you feed them. Garbage in, garbage out. Usually, data is spread across multiple sources, including internal, external, public, and even purchased datasets. Basically, the data needs to be collected, moved, transformed, and stored before being utilized in machine learning. AWS has a wide range of services to move, transform, and store data. Big data services such as S3, Redshift, EMR, Glue, DynamoDB, etc. are out of the scope of this presentation, but they are absolutely crucial for the success of a machine learning pipeline. After we have created a unified access method to our data, the data scientists start their work. They look deep into the datasets and engineer features which best help the desired prediction outcome. When the features are engineered, the model training starts. This is usually a compute-intensive operation, especially in deep learning's case. Ideally, data scientists will love to train models as fast and obviously as cost-effective as possible. When training is finished, the accuracy of the models will be measured by feeding some test data and compare the results with the labels of the test data. If the model is good enough as a solution, you can deploy it into production. But if not, you're back to step one. And repeat this process until either ruling out machine learning as a viable solution or adding enough data and features to get the right outcome. This step is usually the most time-consuming portion of a machine learning process. And this is just the beginning. Adding machine learning capabilities to an application is not a set-and-forget thing. By deploying models into production, your work has just begun. You will capture more data, you will feed more data to your models and get more accurate predictions and deploy better versions to production. So as you can imagine, A/B testing of models in production is vital to the success of an ML project. Amazon SageMaker is a managed service which enables data scientists and developers to easily run an entire machine learning pipeline from building models to training them and then finally deploying them into production in a single pane of glass. This drastically improves the time and speed of idea to production for all the parties involved. SageMaker performs these three tasks in a heavily parallelized, scalable, and secure fashion. While it gives you the flexibility of using whatever tool, method, or framework you're comfortable with, without locking you into a specific toolset or methodology. Let's have a closer look. If you have some experience with machine learning and data science, you are quite familiar with the Jupyter Notebooks. For those who are new to this, Jupyter Notebook is a web application that allows you to create documents that can have live code, visualization, and narrative text. This has become the de facto standard for manipulating data and running machine learning applications. SageMaker, right off the bat, gives you a Jupyter Notebook instance where you can load your notebooks without the typical hassles of SSH tunnels, packages, drivers, and source control. Let me quickly show you how to start a Jupyter Notebook instance. I have logged into my AWS console and I'm using the Oregon region. Let's quickly click on the Amazon SageMaker service. In the dashboard, you can see an overview of the jobs I have in SageMaker. Let's click on the notebook instances. I have 3 notebook instances, 2 of them are in stop mode and 1 of them is in service. Let's go through a wizard and create a notebook instance. I'll give it a name. In the instance type, I can either select between T2 instances, M4, or if I need GPU acceleration, I can select P2 instances. You need to give SageMaker access to your resources such as S3 buckets or ECS Docker images. You can either pre-create a role in IAM or go through a quick wizard. Here you can specify certain S3 buckets, or any S3 buckets in that account, or alternatively any S3 bucket with the SageMaker string in the name, or object with SageMaker in the name, or any buckets with the SageMaker tag and the value of true. Or alternatively, you can create a bucket policy allowing SageMaker access to the data. When it comes to networking, you have a couple of options. No VPC means that you want your instance to run in the SageMaker's services backend network. Or you can attach an ENI to the instance, connecting your VPC subnets to your notebook instance for direct communication. If you select VPC, you have to select subnets and security groups accordingly. You can generate a key in KMS and use that to encrypt your EBS volumes. And to create the notebook instance, we just need to press on Create Notebook Instance. Let me quickly open a notebook. You can start a new notebook by selecting what kernels to run. The available kernels are PySpark, PySpark 3, Spark, Spark R, MXNet with Python 2 and 3, Conda Python 2 and 3, and TensorFlow with Python 2 and 3. You can also upload your existing notebooks to SageMaker. SageMaker comes with a great number of sample notebooks with detailed examples of how to use SageMaker using code. We will review some of these notebooks in the following demos. But to give you a quick demo, we will go to Introduction to Amazon Algorithms folder. And we will look at, for example, the XGBoost multi-class classification using the MNIST handwritten digits dataset. Let's quickly open the notebook. Here is an introduction, and then the notebook is talking about how to ingest the data, converting the data to the final format, and then starting the training job using the SageMaker training feature. And then finally, deploying the model into production. When feature engineering is completed and you have created training, test, and validation datasets, it's time for training the models. There are numerous algorithms being used to train different models using different supervised and unsupervised methods. After talking to many customers and observing the data science world, we've integrated 11 commonly used and popular algorithms in Amazon SageMaker. They are heavily optimized for AWS and are orders of magnitude faster than their implementations anywhere else. If you are interested in getting more details around the Amazon SageMaker's pre-built algorithms, please attend the next session, which will provide you with an overview of the top 10 most common algorithms. Whether it's k-means clustering for data segmentation, PCA for dimensionality reduction, or factorization machines for recommendation engines, the popular XGBoost, or the good old logistic and linear regression algorithms. On top of that, we have done a ton of work to optimize MXNet and TensorFlow for Amazon SageMaker, and we are working on Cafe 2.0 at this stage. It is important to understand that it doesn't mean that you cannot use any other frameworks and algorithms out there. We strongly believe that our customers must have the freedom to choose their own algorithms, tools, frameworks, and we continually optimize the platform for all of those based on the customer demand and feedback. Once you've picked the algorithm, training is so simple. You submit your training jobs, specify what instances and how many of them you want, and we will run the training for you. And at the end, we save your model artifacts in S3. Let's cover this in a bit more detail on how you can submit training jobs to Amazon SageMaker. There are 4 main methods of training using Amazon SageMaker. As we've covered, one of the most efficient ways to train models is to use one of the built-in and heavily optimized algorithms in Amazon SageMaker. Let's have a closer look. Okay, to view the training jobs, click on Jobs. You can see a list of training jobs I have previously ran in Amazon SageMaker. We will go ahead and create a training job. Give it a name, and we've covered the IAM role. In the Algorithms drop-down menu, you can see a list of algorithms. The first 11 items are the pre-built algorithms. Let's select linear learner for binary classification and linear regression, for example. In the hyperparameter section, you have all the common hyperparameters for both types of regressions. If you have experience with machine learning, you are quite familiar with those settings. For example, the predictor type could be binary classifier or a linear regressor. Or for optimizers, you can select between atom or stochastic gradient descent. As I said, there are so many detailed notebooks in your notebook instances, which covers all use cases with Amazon SageMaker. Let's quickly show you the linear learner's notebook example. An intro to the MNIST handwritten digits dataset, setting up roles and S3 buckets, ingesting the data, inspecting the datasets, uploading the data to S3, and this is where you start your training. Here you are seeing the locations of the linear learner's Docker images that AWS publishes and maintains. You need them to run your training code. This is where you submit your And this is where you submit your training job. Import your libraries to establish a session to Amazon SageMaker. Define the training parameters using estimators. For example, the number of instances in the cluster, type of those instances, model output location, and then you define the hyperparameters. In this notebook, we are using binary classifier with a feature dim of 784, which if you're familiar with the MNIST dataset, it is the number of features in each image. And then the mini batch size of 200. After defining all of this, you simply call fit, and your training starts. So you might ask, how about my existing models? How can I train models without using those Amazon SageMaker's built-in algorithms? Models you might have developed using scikit-learn, R, PyTorch, CNTK, TensorFlow, and MXNet. That is also completely fine and super easy to do. Let me show you how easy it is to bring your own models. We'll go back to the training jobs menu and create a training job. In the algorithms menu, this time we select custom. To bring your own custom model, you need to provide with the location of the Docker image which has your training code. For example, in my ECS console, in the repository section, I have an image test which has the code I have developed using scikit-learn, for example. I'll copy the URI and paste it here. By assigning a role, I give Amazon SageMaker the permission to pull down that Docker image and start a training job. And then defining the instance type and count, stopping conditions, and I will cover input and output sections later on in the demos. In the advanced functionality folder under the sample notebooks in your notebook instance, we have a few samples of notebooks on how to package up and bring your own models you may have developed in R, scikit-learn, and TensorFlow. Let's look at the scikit-learn code. It is a decision tree notebook which firstly goes through when you should bring your own models, gives an overview of the Docker packaging process, how your folder structure should look like inside your container. This is the Docker file with all the libraries and packages needed. And finally, the env parameters to execute your training code. This cell talks about how to push your containers to Amazon Elastic Container Service, and eventually we get to the training section, establishing a session to Amazon SageMaker, defining your training parameters, which is pretty much like the previous example with the difference of a custom Docker image location. Now, you can simply call fit and your training job starts. The third method to train TensorFlow and MXNet models is to use Amazon SageMaker's Python SDKs, which are basically an extension to the normal TensorFlow and MXNet code. You can easily use functions to pass training and evaluation data and call fit functions to train your models in Amazon SageMaker. This hugely saves your time and reduces the learning curve of yet another machine learning tool and lets you use what you're comfortable with. There are many pre-built notebooks in the Amazon SageMaker notebook instance, which has great examples on how to use TensorFlow and MXNet Amazon SageMaker SDKs. Let's have a quick look at these notebooks. Folder of your Jupyter instance, there's a folder called SageMaker Python SDK. In this folder, we have a bunch of examples on how to use K-means, MXNet, as well as TensorFlow code to use their high-level SDKs to submit training jobs to SageMaker service. For example, in the TensorFlow side of things, you have code examples on how to use keras as the front end, how to use layers, how to do distributed training on multiple machines or a cluster of machines in TensorFlow, as well as using estimators. For an example here, let's quickly review the estimators TensorFlow notebook here. This is a familiar notebook. If you've used TensorFlow, you've definitely come across this dataset of iris flowers, which uses it's in the quick start section of the TF estimator in the TensorFlow website. So we're using the same notebook with a bit of a change on basically running the training not on local machines but on SageMaker service. So you load that CSV dataset, and this is your iris DNA classifier Python code, which you can find them in the same folder as your notebook, which defines the parameters for your training. And then you create a TF estimator in SageMaker with all the features and all the parameters, the hyperparameters you want to use for the training. And at the end, when you want to train your models, all you can do is to establish a session to SageMaker, import SageMaker TensorFlow extension SDKs, and here's your Python code, the role name, all the good things that we've seen before, the parameters for training, and then hyperparameters for your model. You'll say where to get the data, and so easy, you call fit. As the fourth method of using Amazon SageMaker as a training platform, you can integrate Apache Spark to submit your training jobs to Amazon SageMaker. There are so many customers who already use the powerful Spark ecosystem to do massive scale number crunching and data preparation. To enable those customers to run training right from their Spark environment, we have created Apache Spark libraries for both Python and Scala using your Spark SQL data frames. Okay, we glanced over a few important configurations in the training section in the previous demos. Let's review them again. So we talked about algorithms, and here is the rest of the training configuration. Resource config is quite self-explanatory, choosing between the available instance types, how many instances, and the size of the attached EBS volume. KMS encryption key to encrypt the EBS volume. And here you define the maximum runtime of a job in seconds, minutes, hours, and days. Input data configuration is where you tell Amazon SageMaker from where you get the training, validation, and test datasets to feed to the algorithm. Here we define the name, content type, which is the MIME type of the data. Compression type is for when you are feeding your data in the pipe mode. Record wrapper. If you're not familiar with Record IO, it's a data format created by Apache MXNet which works best with machine and deep learning. It is much smaller in size, much faster in read time, and it allows you to pack data in a parallel setup. In general, using the data format like record IO will speed up your training compared to the raw file types such as JPEG, for example. Here in the configuration, Amazon SageMaker can wrap your data in record IO format if the data is in its raw form, but your model requires record IO. And here is where you define for Amazon SageMaker where to find the objects in an S3 bucket, either in a manifest file or under a typical key name. The distribution type is for situations where you're using more than one machine to train. Here it says a full copy of data to be replicated to every host or to be split in n segments, where n is the number of machines in the training cluster. You can create up to 8 of these data channels. And here's where you specify the destination to save the model after a successful training job. And optionally encrypting the model with a KMS key. When the training is over, the data scientists spend a lot of time on fine-tuning their models to get better accuracies and to run faster. This process is also called hyperparameter optimization, or HPO. HPO is usually a painful and long process and requires lots of trial and errors. In Amazon SageMaker, we have built a feature which does HPO automatically by spinning up multiple training jobs in parallel and run hundreds of different combinations of algorithm parameters. A lot of our customers are super excited about this. At this stage, HPO is only available in private beta, and hopefully it becomes generally available soon. Now, let me tell you all about the great deploy feature of Amazon SageMaker. One of the common bottlenecks of having a machine learning solution in production is when the project comes out of its data science phase and now needs to be deployed in production. It is not fair to generalize, but usually creating, running, scaling, and securing low latency API endpoints in production is not within the core skill set of a data scientist. It takes a lot of iterations and in-depth DevOps knowledge to run a scalable API endpoint which can serve millions of requests and is capable of doing A/B testing of different models. To remove that friction point for machine learning teams, Amazon SageMaker enables you to put models in production with a few clicks and even set up A/B testing of multiple models. It will set up auto scaling and load balancing across multiple availability zones and handles the traffic you throw at it, all without any manual work from your developers or data science teams. Let's quickly see how to put models in production. A model in Amazon SageMaker's definition is a combination of a model artifact, which is the outcome of a training job, plus the inference code that consumes the model. If you are using Amazon SageMaker's built-in algorithms or Amazon SageMaker's TensorFlow and MXNet Python SDK, you don't need to create an inference code / container, as the Amazon SageMaker service does it automatically for you. But if you're bringing your own models, or if you've done training somewhere else and you only want to use the hosting service, you need to containerize an inference code and submit it along with the model. To create a model, here is the inference Docker image location in ECR. And here you provide the location of the model artifacts in S3. And optionally a DNS name for the container. Now that we have the model and the inference code bundled together, we need to define how we would like to deploy it in production. This is where you define configuration for production deployment and A/B testing. Give it a name. Optionally an encryption key. Add the model or models here. Select from one of the previously saved models. As an example, we add another model in a scenario where, for example, I have trained 2 models using the same dataset but with different hyperparameters. Then we edit the production variant of each model. A descriptive name, instance type, how many instances to be launched. And remember, if you select 2 or more instances, Amazon SageMaker launched them in 2 separate availability zones for high availability purposes. And then the traffic weight assigned to this. In this case, we want 75 weight points of the traffic to go to our main model. We repeat the same process for our second model. This time with only one instance and the initial weight of 25. So I have created an endpoint config which has two models in production producing the same prediction with different hyperparameters. One is receiving 75 weight point of the traffic on two instances, and the second one is receiving 25 weight point of the traffic on one instance. Your models are not yet live in production. To deploy them in production, you go to endpoint menu, and create an endpoint. Give it a name. Select the recently created endpoint config and click on Create Endpoint. This will take some time, and then you have your models ready to serve traffic. You get more info when you click on the endpoint. Creation time, last updated time, and there's a bunch of metrics around the model performance and the underlying container and instance. Now that the models are in production, you can make inference calls using SageMaker runtime API calls available from all of our SDKs. In today's session, we have covered an overview of a typical machine learning pipeline. And then we reviewed the three main capabilities of Amazon SageMaker, which are build using Jupyter Notebook instances, train using 4 different methods, and then finally deploying the models into production using the service. Please note that each of these 3 modules are completely separable, meaning that you can, for example, train your model somewhere else, but deploy them into production using Amazon SageMaker, and vice versa. Now, I'd like you to take these 2 takeaways from today's session. Get your QR code scanners ready. Firstly, go to Amazon SageMaker in AWS console and launch a Jupyter Notebook instance. There are lots of sample notebooks with detailed explanations and instructions to use different algorithms for a great number of fun machine learning and deep learning projects. Also, visit the Amazon SageMaker documentation for detailed explanations of what we've discussed today. Second is the Straight Dope. If you haven't come across the Straight Dope, it is an open source collection of notebooks to teach deep learning from scratch to the advanced levels using MXNet and the Glue1 interface. It has a huge number of notebooks covering from the linear regression to convolutional neural networks and LSTM and performance optimization. If you are a data scientist and want to contribute to this awesome project, we would love to hear from you. Okay, if after today you're wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Finally, I would like to thank you for attending this session today and sticking around until the very end of the presentation. Please take the time to provide feedback on today's event so we can improve the event experience for you in the future. Thank you.